Today I am going to show you why there are no real solutions to satisfy two equations, which are x plus y equals 6 and x, y equals 36. One way people would try to do is test integers and see if equations are true, like 5 and 1, which adds to 6 but multiplies to 5, not 36. Some try 3 and 3, which is indeed 6, but it multiplies to 9. Some even try to be slick by using negative numbers, but they have to idea that a positive times negative is negative, like 7, and minus 1, which adds to 6 but multiplies to minus 7. However, some know that a negative times negative is positive, so they try minus 6 and minus 6 because they know the product will be 36, but when you add them you get minus 12, and minus 12 is not 6, so this trick also doesn't work. Some try larger numbers like 12 and 3. The product is 36, but the sum is 15, so try 18 and 2. The product is 36, but the sum is 20. Some try 6 and 6. Product is 36, but the sum is 12, and 6 is the lowest number they can get to. So many players are like, it's impossible. There's no way this equation can be solved. But they haven't mathematically proven there is no real solutions. So in this video I will construct a graph to prove there is no solutions, where it also tests values of x and y, but each line will focus on one equation, and once we compare we will see if they touch or not, giving us an obvious answer. Just a little bit more, and now my graph is done. As you can see here, I chose the limit as 50 since 36 is less than 50, giving me huge space to plot my points based on x and y values. Why plot points on a graph? It will help me draw the lines to improve more accuracy, and it will exactly tell me if the lines touch or if they don't, which will either tell us if there are real solutions or no real solutions. Now that I have constructed the lines, I can clearly see they don't touch, which tells me there is no real solution. The linear line is the equation sum, x plus y equals 6, and the curved line is the equation product, xy equals 36. But hold on, pause for a moment. While there may be no real solutions, there is also another way we can prove this. And this is by solving algebraically. Here we had x plus y equals 6 and xy equals 36. First we isolate y from each equation, so this becomes x equals 6 minus y, and x equals 36 divided by y. Since both right sides each equal x, then they also must be equal, so 6 minus y equal 36 divided by y. Next we multiply both sides by y. On the left side you distribute the y to 6 and y. So this becomes 6y minus y squared, then merge the terms to get minus y squared plus 6y, then subtract 36 from both sides to get a quadratic, minus y squared plus 6y minus 36 equals 0. This is not a perfect quadratic, so we have to use the formula, which is minus b plus or minus square root of b squared minus 4. C all over to it. The coefficients are a equals minus 1. B equals 6, C equals at 36, so plug the values in the formula. Now that the values are plugged in, I will use variable substitution, where D will equal the discriminant inside the radical. The equation has three possibilities, with each being a 33.33% chance of happening. If D is positive, you get two real solutions. If D is 0, you get one real solution. And if D is negative, you get no real solutions. Let's find out. 6 squared is 36. Minus 1 times minus 36 is 36. 4 times 36 is 144. 36 minus 144 is minus 108. Oh look, D is negative, which indicates that this equation have no real solution. This is because if we plug minus 108 for D inside the formula, you get square root of minus 108, and in the world of real numbers, you can't take the square root of a negative number. We are basically saying what number ties itself is negative, but any squared number is always positive, so we must step into the complex world, which are imaginary numbers, or I. We will first factor out integers from this minus 108, which is minus 1 times 108, and this 108 is 36 times 3. Now using the rule square root of a b is square root of a times square root of b, so separate the roots. Square root of 36 is 6, and square root of minus 1 is imaginary, or I, and we keep square root of 3 just the way it is. Now we have 6i times square root of 3. 2 times minus 1 is minus 2. Now we can separate this using plus or minus sign. Now by dividing minus 2, minus 6 becomes 3, and 6i becomes minus 2i. The other side is the same thing, but it uses plus sign. So now that we have two complex solutions, which are 3 to 2i, 3, and 3 plus 2i, 3, we substitute those to find x, and this becomes x equals 6, 3 2i, 3, which is x equals 3 2i, 3, and the other one is x equals 36, 3 2i, 3. So we have 6 complex solutions. Now I won't waste time verifying my 6 solutions, but if you want to try to but do it properly, cause one wrong move may lead to an accidental inequality. Anyways, thanks for watching this video, and I hope you stay tuned for more of these.